Remember just a few short years ago when AI-generated video basically meant these weird, glitchy, silent clips that barely made any sense? Well, today, wow, we are seeing a massive, massive leap. We're talking about generating perfectly coherent, high-resolution videos with realistic motion, lighting, and sound that look, honestly, almost Hollywood-ready.
Which naturally brings us to a huge question. How exactly does AI pull this off? How does it create these incredible videos without a single camera, actor, or animator? Well, today, in this explainer, we're going to take a journey together to uncover the actual mechanical, highly understandable process behind this seemingly magical tech.
Part 1, Carving Video from Noise, Diffusion Models. Let's look at the core engine that's powering most of today's AI video generation tools.
Okay, let's dive into this. Most of the tools you're seeing right now, they're built on machine learning systems called diffusion models. And basically, these systems learn to create by reversing a process of random noise corruption. So during training, the AI is fed literally millions of real videos that have been progressively corrupted with random static. It studies them very closely to learn how to predict what the clean video looked like at each individual step. It's effectively learning how to reverse the damage.
Think of the AI like a master sculptor. It starts out with this rough block of raw marble, right? Except in the digital world, that block is just pure random noise. Then, guided entirely by your text prompt, it gradually starts carving away that noise step by step by step. It effectively denoises that static block until, boom, a perfectly coherent, brand new video emerges that has never existed before. It's wild.
Now, generating a single realistic image is tough enough, but video? That brings us to part 2, the problem of time, visual consistency. Because let's face it, generating 24 unique frames for just a single second of footage is exponentially harder than making a still picture.
And that's because a video model has to keep objects, faces, and backgrounds perfectly consistent from one frame to the exact next frame. Now, there are two main approaches here. On the left, we have frame-by-frame extension. This is where the model makes a starting image and then guesses how the very next frame should change, literally one picture at a time. But then on the right, we have spatio-temporal generation, and this is a total game changer. This is where the model treats the entire video as one giant 3D block of data, so width, height, and time. It actually denoises the entire clip all at once. And as you can probably guess, this 3D block approach tends to produce much, much smoother and physically consistent motion.
But of course, when models struggle to maintain that consistency over time, things can get pretty weird. You've probably noticed some of these common glitches floating around online. You've got object permanence errors, where a car might just completely vanish between frames. Physics violations, think water flowing backward or limbs bending in ways they definitely shouldn't. Temporal flicker, where the lighting just entirely changes from second to second for no reason. And finally, prompt drift, where by the end of the video it's just gradually forgotten the text prompt it originally started with.
So, how do we actually instruct the AI on what to carve out of that noisy block in the first place? Well, let's move on to part 3, text versus image input methods.
Now, what's really interesting about this slide is how creating from a text prompt differs from animating an uploaded still or restyling existing motion. We basically have 3 main input options. First up, text to video. This is creating from pure scratch. You type, say, golden retriever running through a field at sunset, and it builds the whole shebang. But image to video is super fascinating. You upload a still image, and the model animates it. It adds camera movement or action to an existing picture while keeping the original content totally intact. Finally, video to video allows you to completely restyle existing footage, so you could turn a live-action clip of yourself into a slick animated cartoon while preserving your exact original motion. Oh, and by the way, these aren't just silent movies anymore. This visual magic is usually paired with a totally separate audio pipeline. AI tools can sync generated text-to-speech right to the video, and even more impressively, the newer systems are generating synchronized ambient sound and sound effects right alongside the visual generation itself.
All right, let's zoom back out to the macro view for a second to answer why this matters right now. Part 4, real-world applications, reshaping creation.
The absolutely crucial takeaway here is that this isn't just some fun toy. It is actively reshaping how we create content. We are already seeing very concrete, immediate use cases. Educators are turning dense written texts into short, narrated explainer videos to help students. Marketers, they're rapidly prototyping ad concepts before blowing their entire budget on a massive production shoot. Filmmakers are using it to visually storyboard their scenes, and it's even being used for accessibility, converting text-based study materials into narrated visual formats for entirely different learning styles.
But let's keep this explainer grounded. There are some real, current limitations we definitely need to keep in mind. Narrative coherence still really maxes out at about 1 to 2 minutes. So no, you aren't generating a full-length feature film just yet. Also, the compute costs are massive. That means it can take 10 to 30 minutes or more just to generate one short clip. And importantly, major copyright and likeness questions remain completely unresolved in a lot of jurisdictions right now.
Still, despite those limitations, the leap forward we've seen is absolutely staggering. We've gone from rough static noise to realistic motion in the blink of an eye. So, as AI continues to master the mechanics of motion and effectively hands you the digital chisel, what will you carve from your blank block of pixels? Really think about it. Thanks for joining me on this explainer, and until next time, keep exploring.